If we decide to implement a public key infrastructure, it turns out to be extremely functional and useful for various applications. Right now, we'll just take a brief look, and in a moment, we'll return to individual cases. What can we do with a certificate? First of all, we can verify the identity of internet services. Probably no one would decide, for example, to use electronic bank services if the communication from the website of that bank took place using HTTP instead of HTTPS protocol. It would be the same if communication was already established using HTTPS protocol, but the bank's website presents an invalid certificate. Currently, almost all internet browsers help us with this. If the certificate is invalid for some reason, we'll speak about this later, the browser blocks displaying the given website and warns us before we visit the site that something is wrong with the certificate. It may also do so on the address bar. Rather than the soothing green color of the address bar, it's red, which should draw our attention to the fact that something's wrong. If we don't pay attention to it, then we fall victim to a dual attack. First of all, man-in-the-middle attacks, which we've already talked about. Someone controls the channel between us and the bank's website, and we really connect to the bank through the attacker. The certificate of the attacker was displayed to us. That this does not match the bank's address is signaled, for example, in red. If we write there any of our confidential data, it will be encrypted, but the attacker's key will be used. This doesn't make any sense. The second type of attack is spoofing the bank's website. Very popular attacks at one time were based on attackers registering domains whose names very much resembled the original domain name. They used various tricks to do so. For example, double encoding, or they used suitable words of a given language in encoding the domain name. Domain names may be regionalized. Because we display it on our side of the code, we see, for example, the letter O, as it should be in the name of a given bank. But in fact, it could be, for example, the letter O with an umlaut. Contemporary browsers also protect us from such attacks. Another use is encrypting file system, meaning the possibility to encrypt files. Another is digital signatures. We can prove that we're the sender of a message and convince the recipient that no one has modified it by signing it digitally as described in one of the earlier modules. Logging into systems using a smart card is also used in public key infrastructure. On the smart card is written our certificate with some private key. Secure electronic mail, SMail. Everything is based on certificates and on public key infrastructure. If it weren't for that, there's no point to encrypt something if we don't know to whom it will be sent. We're not able to confirm the identity of the recipient. Certificates also permit code signing, not only signing data, but also code signing. Fortunately, more and more programs are digitally signed. If it comes to such a situation that all programs will be signed digitally, we will be able to implement in our systems a simple policy stating, do not run unsigned code. With regard to signed code, run programs from this publisher and that publisher. We will be safer. Since we can identify code, on this basis we can make some decisions. Software restriction principles work in the way we just mentioned. One of the methods of code identification is these certificates used to sign it. Secure Internet Protocol is based on using public key infrastructure. We must somehow authenticate the other person. A certificate may be used to do this. This is a significantly safer method than a shared key. Also in the group is the 802.1x standard. We've already mentioned it during our training. It may use certificates to authenticate both users and computers, workstations, and laptops. In the central part of the scheme shown previously, there is a model structure of the public key for medium-sized companies. We'll have a root certification authority, often referred to as root. Another will be subordinate certification authority, which in contrast to root, will be online and will perform all requests on a regular basis. At the very bottom of the hierarchy are functional certification authorities, which will issue certain types of certificates. We'll explain in a further part of this module why it should look this way.